أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم Assalamu alaikum dear student. Today our topic in applied mechanics is force. First of all we will know that what is force. Basically force is push or pull of an object. When we applied force on a body to push it or to pull it, then it's called force. Push or pull of an object is considered a force. Got it? Push and pull came from the object interacting with one another. From where push and pull came? Basically when more than one object, 2, 3 or 4 objects interact with each other, it must be somebody will push the other one or pull the other one. Term like stretch, how when just stretch a rubber or squeeze a foam, can also be used to denote force. Stretching and squeezing also used to denote forces. Second definition of force is an external agent capable of changing the state of rest or motion of a particular body. Basically force is that agent which cause change to the state of body. Suppose a body is at rest and we apply force on it, and it produces some motion in the direction of force, so it's changed the state of body from rest to motion, so it's called force. Or a body is moving with the uniform acceleration, or a body is moving with the speed, and we apply force on it to just lay down and to rest, then we also call it force. Force is basically that agent which cause changes to the state of a body. If it's in rest, it will give motion. If a body is in motion and we want to stop it, then we also apply force. To determine force we need both magnitude and direction. It means that force is a scalar quantity. Okay, for force we need both magnitude as well as direction. Where will be the direction of force? Direction of force will be in the same way in which we applied force. Got it? In which direction we applied force, the direction of force will be similar to that. And the application of force is the point where force is applied. And where we applied force, that are the application. Suppose we are just throwing a ball. We applied force by hand. Got it? And in which direction we throw the ball? The ball goes in their direction. So our application is thrown ball, and the direction of force is given by our hand, that, and if we want to throw it in left direction, right direction, upward, so there will be its direction. The SI unit of force is Newton. We can measure force by simply a spring balance. If we put some weight on it, and it will directly change in directly proportional with respect to that weight or force, so it shows by spring balance. If we want to find the force, we can use spring balance. The SI unit of force is Newton. Got it? 1 Newton is equal to that much force. If we applied a force on 1 kg of body and it produced acceleration 1 meter per second in that body, so that force is equal to 1 Newton. The force has different effect, and here are some of them. Force generate different effect on body. Some effect of these are here. Force can make a body which is at rest to move. Simple. If a body is at rest and we applied force on it, then it will change its state, and it will produce some motion in that body. It can stop a moving body or slow it down. Force can also be used to stop a moving body or to slow down its motion. Suppose a car is moving with the velocity of 120 km per hour and we applied brake suddenly. What is the phenomena of brake? Because brake is applied to slow down the motion of that car. So we applied force on it. Hydraulic forces, hydraulic mechanism are used, different mechanical mechanism is also used, but our main concentration is to slow down that car, that vehicle, so it slow down the motion of that body. Or we have a ball, cricket ball, simply coming toward us. We just goes our hand in the direction of that ball and we applied force in opposite direction and we stop the movement of that ball and we catch it. It can accelerate the speed of a moving body. If a body is already in motion and we applied more force, then it will increase the acceleration of that body. It can also change the direction of a moving body along with its shape and size. Yes, if a body is moving in one direction and we applied force in different direction, then it can also change the direction of their body. If we applied force on a body and stretch it, then it will change the shape and size also. Squeezing or stretching is the difference in shape and size. Now we are going toward a very important topic, that what is a force system. Basically, when force is applied on a body, it's not a singular force. It's combination of different forces, action and reaction forces. That's why a body remain at rest. So whenever we are going to study the body, that how it is in rest or how it is moving with uniform speed, then we have to study different forces on it. So if we are going to study more than one forces on a system, then we will call it force system. Okay, in force system we will study more than one force and we will study the effect of more than one force on a system. A force system may be defined as where more than one force act on the body. Got it? It's mean that whenever multiple forces act on a body, we term the force as a force system. Simple. If we are going to study the effect of forces which is more than one on a body, we will call it force system. Force system can be classified into groups and subgroups or category and subcategory depending upon the nature of forces and point of application of the forces. Almost any system of known force can be resolved into a single force called resultant force or simply resultant. As we studied in previous classes that in head to tail rule, the vector will start from the tail of first vector and end at the head of last vector is called resultant. If we just find the resultant of, if we just want to find the whole system in one vector, then we will go toward resultant. Okay, if we want to show the result of all these forces in a singular vector, then we will consider resultant vector and we will call it resultant. The resultant is representative force which has the same effect on the body as the group of forces. Resultant is basically the representation of all forces acting on a body. One single force can represent any number of forces and it's very useful when resolving multiple group of forces. It's important to note that any given system of forces, there is only one resultant. Which system you want to use, there will be only one resultant. Now we are going toward different type of force system. That how many force system we have, and what are the difference between that forces. Coplanar forces. In coplanar forces, before starting this, we are going toward the diagram. Look, in coplanar forces, all the forces will act in one plane. The forces which acting in one plane are called coplanar forces. In this system, all the forces will be in one direction. It must be in x plane, all the forces, or it will be in y plane, or it will be in z plane, but all the forces will act in a similar plane. Now come toward its definition. If two or more forces rest on a plane, then they are called coplanar forces. If two or more than two forces act on one plane, then these forces are called coplanar forces. There are many ways in which forces can be manipulated. We have different ways to calculate or to demonstrate different forces. It's often easier to work with a large complicated system of forces by reducing it over decreasing number of smaller problems. This is called the resolution. If we divide forces into its part to resolve a vector into its component, is called resolution of vector or resolution of force vector. This is one way to simplify what may otherwise seem to be impossible system of force acting on a body. It is the simplest way to solve the problem of force system, that we have to resolve that vector into its component, and we call this method is called resolution of vector. Certain system of forces are easier to resolve than other. We have different forces which are easily to resolve, but we also have some forces for system which are not easy to resolve. Coplanar forces system have all the forces acting in one plane. They may be concurrent, parallel, non-concurrent, or non-parallel. In coplanar forces, as we know that all the forces must be acting in one plane, so these forces may be concurrent, parallel, non-concurrent, or non-parallel. All these systems can be resolved by using graphic, static, or algebra. If you want to find out the resultant, we can use any of these three methods. We can find it by graphical method, as we studied head to tail rule, static, or an algebraic method. And this is the diagram of coplanar forces. Look, here is the direction, all the forces acting on one plane, that's why we will call it coplanar forces. Now we are coming toward concurrent forces. A concurrent coplanar force system is a system of two or more forces whose line of action all intersect at common point. Look at the diagram. Those systems in which all the forces acting in one plane and its center of action is same. All the forces are on O and O point, that's why we call it concurrent forces. Okay, two or more forces whose line of action all intersect a common point. All the forces are intersecting at a common point, that's why we call it concurrent forces. However, all of these individual vectors might not be actually in contact with the common point. They are most simply force system to resolve with any one of many graphical or algebraic options. This system is the easiest system to resolve by graphical or algebraic option. If the line of action of two or more forces passes through a certain point simultaneously, then they are called concurrent forces. Look, if the line of action of two or more forces passes through a certain point simultaneously, then they are called concurrent forces. If the line of action of two or more forces passes from similar point then these forces are called concurrent forces. Concurrent forces, remember, concurrent forces may or may not be coplanar. It's not necessary for a concurrent force that it must be coplanar. No, it may be coplanar or it may not be coplanar. It means it may be applied in one plane, or for concurrent forces there must be more than one plane. Okay, some force is applied in x direction, some force is applied in y plane, or some force is applied in z plane. Okay, but the action of all these forces will be similar, same. Non-coplanar forces. The last illustration of non-concurrent and non-parallel system. And this non-coplanar forces, there will be different forces acting in different planes. Suppose one force acting in y plane, other force acting in z plane, other force acting in the x plane, but their point of action will be similar. Okay, and it need more concentration to resolve it, because we have to look at every condition in every degree, and it's difficult to resolve it due to the different plane, all forces acting in different plane. That's why its resolution and its solution for graphical or algebraic method is little difficult from coplanar forces. Now we are going to study like forces. A parallel coplanar forces consist of two or more forces whose line of action are all parallel. Look here, when there is more than one force and the action of the line of action of that force are parallel and it has an similar magnitude, then we will call it like forces. Okay, the magnitude and line of action of that forces are similar, that's why we will call it like forces. In contrast, unlike forces. And unlike forces, maybe the magnitude of forces are same, but their direction is an opposite direction, that's why we will call it unlike forces. Look, the direction of F1 is upward and the direction of F2 is downward, that's why we will call it unlike parallel forces. And like forces, look, the direction of F1 and F2 are in same plane and same direction, both F1 F2 carry same direction, that's why we will call it like forces. It is the end of lecture 4. If you have any query or any question, you can ask me immediately. Take care of yourself, and if you have any doubt or any question, you can ask me. So take care and remember me in your valuable prayer. Assalamu alaikum wa rahmatullah.